Hello viewers, this is Mahmood, and in this video we are going to solve a problem that is related to the graphs of the function and its derivatives. So below you see the graphs of f of x, f prime of x, and f double prime of x. We have to determine what's the graph of f, what is the graph of f prime, and what is the graph of f double prime. Justify the answer that using a sign diagram. So first we are going to make a diagram, or you can say a table, that represents the relation between the function and its derivatives. So let me draw a vertical line here. So the first column represents the function, that is f of x, and the second column represents the derivative of the function, the first derivative, that is what we call f prime of x. And when the function f of x has positive slope on some interval, let's say a comma b, so the derivative of the function has positive y values on the same interval a comma b. Okay, and if the function, let's say this is the first point, and let's say this is the second. The second point is if the function has negative slope on some interval, let's say c comma d, so then the derivative of the function has negative y values on interval c comma d. Okay, so this is basically the relation between f of x and f prime of x. So the same relation is between, if we consider the first column is our f prime of x, so the second column will be our f prime of x. Okay, it means that if f prime of x has a positive slope on a comma b, so f double prime of x has a positive y values on a comma b. And the same way, when f prime of x has a negative slope on c comma d, so f double prime of x has negative y values on c comma d. Got it? So now look at the graph. Here we have three graphs, and we are going to assume that one of the graph is our f of x, and the others are f prime of x and f double prime of x. So assuming that the middle one, you can see here the second graph is our, let's say, f of x, and the rightmost, that is the third graph, is, that is, let's say, our the graph of f prime of x, and the first graph, that is the leftmost graph, is over the graph of f double prime of x. Okay. So first we are going to find the critical points. you know the critical points are those points where the function derivative is zero. You can see here, this is the point where the slope of the tangent line is zero, and this point is basically the critical point. Okay, and the same way is here. the slope of the tangent line becomes 0. This is another critical point. And the third critical point is here. So it means that we have three critical points. And this function has three local minimum or maximum values. Okay. So let me call the first point, that is A, and the second point, let's say B, and the let me call, let's say x1, x2, and x3. This is my x1, this is x2, and this is my x3. Got it? Now, the derivative of the function on those points, on these points x1, x2, and x3, the derivative of the function would become 0. We can say that the graph of the derivative of the function will passes through the x-axis on those points. You can see here, the first point is here, that is our x1. The second is x2, and the third one is here, that is x3. You can clearly seen that these are the points on the x-axis, and the graph of the f prime of x passes through these points. Okay, so now we divided the whole interval, the whole x-axis, into 4 parts. That is, on negative infinity, this is our negative infinity to x1. You can see that negative infinity to x1, and the second one is from x1 to x2, and then from x2 to x3, and the last one is that is from x3 to positive infinity. Am I right? Okay, now you can see that we are looking the values of the slope of the function. So you can see from negative infinity to x1, and what's the slope of the graph? You can see that, let's say, the slope is negative. You can see the slope is negative. So we can say that from negative infinity to x1, what's the slope of the graph? So that is that is negative. And f prime of x, you can see here. Now we have to check that what are the values of the y, they are positive or negative. So you can see that this is from negative infinity to x1, then x2, then x3, up to positive infinity. So you can see from negative infinity to x1, the values of y, they are negative. Okay. So it means that is true from negative infinity to x1. And the second is from x1 to x2. Now you can see from x1 to x2, the slope of the graph is that is positive. You can see here. So we can say that from x1 to x2, the graph of f of x has a positive slope. So that is positive. Okay. Now we have to look here the values of y in the derivative of f of x. So you can see the derivative of y, the derivative of the function has a positive y values. You can see on this interval from x1 to x2, the y values are positive. So that is also true. Okay, now from x2 to x3. So from x2 to x3, you can see that the slope are again negative. The slope is again negative, and on the derivative of the function graph you can see here the values of y are negative again. And now on the third interval, that is from x3 to infinity, this is x3, and here we have that is our positive infinity, and you can see that the graph has positive slope. You can see, okay, so that is going to be a positive slope. And now we are going to check the y values of the f prime of x, and you can see the y values are, they are positive here. Okay, so that is true for the function f of x and f prime of x. So up to here our hypothesis is true. Our hypothesis was, the middle graph is f of x, and the rightmost graph represents f prime of x. Now we have to check whether the first graph represents f double prime of x or not. So now the relation is in between f double prime of x and f prime of x. Okay, so now what will we do? So we have to, find the local maximum or minimum values here. So here we are talking about that this is represent our f prime of x, and this graph represents f double prime of x. Okay, so now you can see the first local maximum is here, and the second maximum is somewhere here. Okay, sorry, the local minimum, this is the local minimum value. Okay, so we have two critical points on the x-axis, and the derivative of f of x would be, passes through these two critical points. You can see the first critical point is here and the second critical point is here, and the graph of the derivative of f of x, that is f prime of f double prime of x, we can say that f prime of x whole prime, so this is the graph, you can see passes through these 2 points. So let me call this is my x1 and this is my x2. So the same is here, that is x1 and that is x2. So now we have to make here a table that is from negative infinity to x1. So that is negative infinity to x1, that is the first interval, and that is from x1 to x2, this is my second interval, and the third interval is, that is from x2 to positive infinity. Okay, and now f prime of x, you can see the slope of the f prime of x graph from negative infinity to x1 is positive or negative. That is clearly positive, you can see. So from negative infinity to x1, the slope of f prime of x is positive. And what about the y values on f double prime of x? And you can see clearly the values are positive. The y values are positive, you can see here. That is above the x-axis. So they are also positive. And now from x1 to x2, you can see from x1 to x2, the slope is, the slope is negative. Let me draw here tangent line, something like this one. The slope is negative. So we will write here negative. And now we have to check the y values on this interval. of f double prime of x. So you can see that is below the x-axis. So we can say that the y values are negative. Okay. Now the last interval, that is x2 to infinity, and you can see that clearly from x2 to infinity in this interval, the slope of uh, f prime of x is positive. Okay. So we will write positive here. And now the y values of f double prime of x on this interval is going to be positive again. You can see here that is above the x-axis, that is again positive. So the relation between f prime of x and f double prime of x also satisfying. So our hypothesis is true. Our hypothesis was true, that is, we suppose that earlier that the middle one is f prime of x and the rightmost is f prime of x and the leftmost is the graph of f double prime of x. So here, this is, let's say, first graph, this is the second graph, and this is the third graph. So clearly graph graph at a position 2 represents f of x, graph at a position 3 represents f prime of x, and graph at a position first represents f double prime of x. Okay.